Dr. Hilbert here. We are going to look at the rational numbers, which is the set of all fractions, and the real numbers. And we're going to try to put all the rational numbers on a list. And one way you can do it is write all the integers, so 0, 1, -1, 2, -2, etc., and put them all over 1. And then write all the integers except 0 on the list again and put them all over 2. Now you might notice that 4 over 2 and -4 over 2 is missing, but they're already on this list. So you don't want to repeat these things, but you can generate all the fractions with 3, all the fractions with 4, all the fractions with 5 in the denominator, etc. So a fraction, a rational number, is an integer over an integer. Can you see all the fractions on this list? Well, there's some ... dots, but yes, if you get far enough on this list, you can put a one-to-one correspondence between the natural numbers and these. And the way you would do it is you would start here, and here's the first one, the second one, third one, fourth one, and you would count them like this. And so that proves, in a not a rigorous way, but that proves that the rational numbers are countably infinite. Now, let's assume we can put all the real numbers on a list. So we can do that with rational numbers, but excuse me. But can you do it with real numbers? Well, the deal is, let's assume you can. And so this list just keeps going. But is it countable? Does it hold all the real numbers? And what I want you to take a look at is this first element here, second element on that number, third element on that number. We're just looking at some real numbers between 0 and 1, by the way. And so we'll show that those real numbers are either countably infinite or not. Fourth, fifth, etc. So what you want to do is you want to say there is a number that is not on this list. So we're assuming we can create a list, and that's our assumption, and we're going to have a proof by contradiction where we assume the real numbers are countably infinite. A number that is not on the list is pick something that is not 5, like 3. Pick something that is not 3, like 7. Pick something that is not 1, like 0. Pick something that is not 1, like 8. Pick something that is not 8, like 9. And you keep doing that. You generate a number that is not on this list, thus proving the real numbers are not countably infinite, which kind of suggests that there's more than one kind of infinity. You have the infinity where you can count things, and then you have an infinity where you cannot count things. And there's actually more than 2 kinds of infinity. Mathematics is intriguing. You will find that it fulfills your life just studying this. Hope you enjoyed seeing these rough proofs.